This is no ordinary car. It's a dream come true. A car that runs on a cheap, safe fuel that's in limitless supply.
The car can be run on any form of natural water. You can use rainwater, well water, city water, ocean water, and if you don't have ocean water available, you can go ahead and use snow. Just use any form of natural water. You don't process it in any way. You add no chemicals to it. Just use ordinary rainwater.
The inventor believes he's found a way of generating some form of atomic power from water. And it was this dream of endless energy from water that was first raised 5 years ago this week.
Couple more. Good. Close the same eye, right in here, please. That's good. That's good. Lovely.
Two respected chemists shot to international fame by claiming to have produced nuclear fusion in a test tube. It became known as cold fusion. Professor Stanley Pons and Martin Fleischmann provoked one of the most bitter debates in 20th century science. That debate is now hotter than ever.
The cold fusion episode will be looked upon as one of the greatest travesties against justice and understanding that has ever occurred in the history of science.
I have labeled my book, Cold Fusion, the scientific fiasco of the century, simply because there's no experimental evidence at this point that any nuclear reaction products have been formed.
They say cold fusion must be real because so many people believe in it. Well, a lot of people believe in flying saucers.
It's been said that we have gone off the wall with our ideas, but that's absurd. Actually, we are extremely conventional scientists. I always say we are so conventional it is painful.
Away from the glare of the media, almost in exile from the scientific mainstream, Martin Fleischmann and his former student Stanley Pons have ignored their critics. They've continued their work as if they'd not been scorned, and in fact, they've scaled up their prototypes. Dozens of other scientists around the world have joined what amounts to a cold fusion underground, and the idea that was officially pronounced dead 5 years ago is attracting multi-million-pound investors.
If it had been anything else, we would have said, oh, you know, people don't want us to do it, forget it, just leave it alone. But this is not in that category. This is interesting science, new science. If you've got any integrity, you don't give it up.
The argument is about whether it's possible to recreate the power of the sun. In the core of the sun, at a temperature of 5 million degrees, atomic nuclei join together, releasing vast amounts of energy in a process called nuclear fusion. Martin Fleischmann and Stanley Pons believe they can recreate the same process on Earth at room temperature in a simple electrolysis experiment. They use heavy water, water in which the hydrogen is replaced by its heavier variant, deuterium, and electrodes made from the metal, palladium. When they pass a current through the water, they claim large amounts of excess heat are produced. When they first announced their discovery in March 1989, they became celebrities overnight. News of the astounding breakthrough was relayed all over the world, and the price of palladium soared on the commodity exchanges.
Dallas radio station has reported that the University of Moscow has just announced that it has successfully repeated the Pons-Fleischmann experiment.
The potential implications of a scientific breakthrough that can produce cold fusion are, at the least, in our judgment, spectacular.
Gentlemen, the world awaits the crucial details of your amazing claim. We all want this to work.
I think we're all transported here.
But not everyone had reason to celebrate. For years, scientists had struggled to generate energy from hot fusion, creating high temperatures within powerful magnetic fields, conditions even more extreme than in the heart of the sun. All of this might be abandoned if the chemists from Utah were right. The fate of $1 billion hot fusion program hung in the balance. Soon, leading centers of physics such as MIT in Boston were flatly contradicting the claims for cold fusion. At the Harwell laboratory in Britain, a team of researchers worked for 6 months. They too found nothing. No heat and no nuclear products, which would be evidence of fusion.
At first you assume it's because you're not smart enough, or not going for long enough, or not doing things quite right. So you try yet more variations. And all the time these claims are coming in from all sorts of people saying, oh, they can do it the first time round. You know, you feel like a right Burke. Here are all these people saying, oh, they switch this cell on and bang, it works. Neutrons come out, or heat comes out, or tritium floods all over the place, and we found nothing.
And in Washington, a special committee to investigate cold fusion convened by the Department of Energy delivered its verdict.
We wrote a very negative report and concluded that the results that were being presented to us were contrary to everything we had found out about nuclear physics over the last 50 years.
For most physicists, cold fusion would be nothing short of a miracle. At the heart of every deuterium atom, there is a strong positive charge carried by protons, shown in blue. This charge prevents the atoms coming close enough together to fuse. But in the sun, enormous temperatures set the atoms moving at great speeds. They collide with force, overcoming the repulsion, fusing, and releasing energy. Pons and Fleischmann believed that in their cells, they had found a way around this repulsion at much lower temperatures, room temperature in fact. Even more miraculous, their experiment didn't produce the dangerous radiation expected from fusion reactions. If they were producing all their excess heat by fusion, the experiment should have produced enough radiation to kill them. For most physicists, 2 miracles was too much to swallow. In March 1990, cold fusion was written off in an editorial in the journal Nature.
I think it will turn out, after 2 or 3 years more investigation, that this is just spurious and unconnected with anything that you would call nuclear fusion, thermonuclear fusion. I think that, broadly speaking, it's dead, and it'll remain dead for a long, long time.
It was beginning to look as though the whole episode was to be relegated to the archives, of interest only to historians of science.
The cold fusion case looks just like many other scientific controversies. You have an initial burst of excitement. I mean, something new has been discovered. That's, after all, what scientists live for. Then you have to try to figure out what it means. And particularly if it's something that challenges the mainstream ideas, there will very quickly be denunciations and claims that this can't possibly be real. What happens next depends a bit on how easy it is to demonstrate how real the phenomenon is.
Cold fusion became a joke, and there was no shortage of souvenirs.
This is the Caltech cold fusion group, which of course was one of the major anti-groups. The test tube in this case has a $sign in it, and the water supporting that $sign, which is of course supposed to be the electrode, is pouring out, and the poor sun down there has failed miserably. This was the cold fusion hat available at the University of Utah bookstore.
The Utah University Department of Cold Fusion Confusion. Fill cup with desired beverage. Insert swizzle stick. Clip wire to swizzle stick and insert other end of wire into cork on end of test tube. Guaranteed to work unless you are from Boston or have any affiliation with Boston physicists.
You forget things in time, you know. I can remember that I was extremely bitter and upset at the time. Thought we'd been treated extremely unjustly, which I still do. Again, I think the critics were not operating within the bounds of sanity. And I think we were victimized in that respect. So I was quite bitter at the time, and I just chose to ignore it and just go on. I really don't have any feelings about it anymore. It's just a non-issue now.
I think you become numb.
You become numb to it, yeah.
By now, fallout from the controversy was even affecting their children, who were being taunted in school. And there were rumors that Pons and Fleischmann had fled from Utah in disgrace and gone to ground. But thousands of miles away, just outside Japan's northern city of Sapporo, a rescue mission was already underway, thanks to the intervention of a former student of Fleischmann, Dr. Keiji Kumimatsu.
Professor Fleischmann is a very creative person and very famous electrochemist who has done a lot of experiments and findings which were thought impossible by many people. One thing which I learned was scientists must do something new which nobody has done before. He said that is the spirit of scientists.
He arranged an interview with one of Japan's leading industrialists, Minoru Toyoda, a member of the Toyota family.
I'm sure in his mind he was already running his cars by the energy produced by cold fusion. Although he didn't understand the detail of the cold fusion, but probably he sensed that the cold fusion may be really a new energy source in near future. So in that case, he was in the position to decide the company policy. So he immediately probably decided in mind to start a new project.
Pons and Fleischmann were offered a new beginning in southern France, just outside Nice, funded by the Toyota empire.
It was exciting to make a move. It was a relief to get away from that terrible atmosphere in the United States and to have the opportunity to work totally without public attention for a period of time.
Toyota's money built a brand new lab, hired staff, and gave Pons and Fleischmann a chance to scale up their experiments.
The initial aim was to re-establish the work, but unquestionably our dominant aim here is to get to a technological application.
They claim they've improved the experimental design and are producing even more heat.
By October 1989, we'd got to 100 watts per cubic centimeter, which is of the order of heat release in a pressurized water reactor. And by the summer of 1990, we had got to in excess of 1 kilowatt per cubic centimeter. And since we have been here, we have got up to about 4 kilowatts per cubic centimeter, which is about the level of heat release you get in what is called a fast breeder reactor. So if these processes can be sustained, they will be powerful sources of energy.
Pons and Fleischmann persist in their belief that there is so much heat coming out of their cells, it must be a nuclear reaction.
We have about 100 times the energy generated, which could be accounted for by any chemical process. So we are quite sure it's not chemistry. Also, it cannot be a physical process of a conventional kind. The only thing it can really be is a nuclear process. So the question is, what nuclear process? In our view, there must be some new nuclear processes.
But there's no agreement on what these new nuclear processes may be, even within the cold fusion underground. Some suggest that neutrons are being switched between the nuclei of the atoms, releasing heat in the process. Others believe that deep within the array of palladium atoms, an unusual clustering of the electron cloud allows the deuterium nuclei to come close enough together to fuse. Another suggestion is that sudden cracks in the palladium effectively fire the deuteriums together. These claims for a new nuclear process are based on measurements of the current put into the cell, compared with heat loss and temperature rise during the entire experiment. They believe they always get excess heat. Critics concede that these are difficult measurements at the limits of detection, but don't accept that there is excess power. What's more, they argue it ought to be reproducible.
Of course, the other thing that you're required to accept in this field is that the fact that the results are irreproducible is an inherent part of it, and an acceptable part of it, one of the characteristics of the system. We weren't able to see it because the results are inherently reproducible. This, of course, makes it hard for people to confirm or deny. And this then makes it very like all sorts of other phenomena, like flying saucers. I mean, I could say, I just saw a flying saucer just go past the window just there. And you could say, well, didn't see a flying saucer. But of course you didn't see it, you weren't looking.
If you do experimental research, especially in surface chemistry, you realize that processes are always irreproducible. A very large proportion of the chemical industry is based on catalysis. And that is a terrible fight. To get the catalysts to do the reactions you want to carry out is a big fight. And really, it's a triumph in the face of adversity. But people have got it under control. If you think of the development of microelectronics, the chips, initially, the reproducibility was a fraction of a percent.
But other scientists believe they've cracked the reproducibility problem. In California, another former student of Fleischmann, Dr. Michael McCoubry, has been working on this since the controversy began.
As far as I'm concerned, there is a phenomenon to be studied. There is a mystery. I have observed something that I cannot explain, and I will continue to work until I understand it.
His research has been funded by some American electricity companies and kept under wraps until recently.
Our sponsors had interests in obtaining patents against the day that a commercial technology might develop from this field. So for the first 2 years, our work was held rather closely to our chest, and we didn't publish very much. We certainly didn't announce all of the results that we had or techniques that we had employed to obtain the results that we had obtained.
McCoubry found that they could always reproduce the excess heat if they managed to achieve extreme conditions within the palladium electrode by forcing it full of deuterium and maintaining this for a long time.
The issue of reproducibility, or its lack, has been frequently misunderstood in this field. The difficulty has been reproducing the conditions which produce the results, not reproducing the results. So if we meet the conditions that we have established, then we, in every case, observe excess heat.
The question of reproducibility has to go beyond one's own laboratory. If someone claims that they're making and doing cold fusion, he has to be able to produce a set of instructions that someone in an independent laboratory can reproduce those results. Reproducibility within one's own laboratory may simply be a result of systematic errors. And with regard to McCoubry's results, McCoubry claims that he has far too much energy to be due to a chemical reaction. On the other hand, 5 years have elapsed, and McCoubry has no nuclear products. And so, if he's going to say it's not a chemical reaction, he has to concentrate on finding the nuclear products, which he has not been able to find.
McCoubry accepts that he hasn't identified nuclear products, but believes, like Fleischmann, that it is a nuclear process. One early experiment provided an intriguing clue. They took a spent electrode from a cold fusion cell and simply exposed it to film.
Very much to our surprise, the second experiment that we performed, P2, after 12 days of exposure to the film, produced a pattern of bright illumination on the first layer of photographic film. For us, this was remarkable. We had had evidence of heat production, and now we had evidence, at least partial evidence, of a nuclear process. Clearly, the key to this business that we're investigating is whether or not there is a heat-producing phenomenon, whether or not there is a nuclear process, and whether the two are coupled. And And we had now two pieces of the puzzle.
But on the east coast of America, results were emerging which heightened the mystery, suggesting whatever's going on isn't a nuclear process at all. It was found by a young scientist who claims he has completely redrafted quantum mechanics all by himself.
I wanted to know how things really worked because I was absolutely convinced that what was the present state of knowledge of how things worked on an atomic scale was inaccurate and incorrect.
Mills was convinced that the cold fusion effect was real, but not nuclear. And furthermore, that 70 years of nuclear physics was wrong as well. As he drafted his own theory of the atom, his calculations predicted that hydrogen, the most common element in the universe, could exist in a totally new form never recognized before. The atomic nucleus of hydrogen is circled by an electron. This can only move in clearly defined orbits. But Mills believes that contrary to orthodox theory, electrons can jump into extremely close orbits. This process would release remarkable quantities of heat, creating a new form of hydrogen.
I was extremely excited. And there were times when I was driving home and I'd be there, oh God, I'm the only one in the world that actually knows this solution. I'd call one of my friends and tell them because I thought, well, what would happen if I crashed on the road and no one would ever know this and they wouldn't discover it for another 100 years.
To test his ideas, he tried to create the new form of hydrogen. He took just ordinary water and passed a current through, creating a device very much like a cold fusion cell, using nickel, not palladium electrodes. These experiments, using just ordinary water, he claims, show up to 1,000% excess heat. His ideas so impressed a high-technology engineering firm, Thermocore, that they began to test the light water in nickel cells as well.
Some of our better experiments with the electrolytic cell have generated as much as 1,000% excess heat. For example, if we put 1 watt into the cell, we will get 10 watts out. And with that kind of heat, we know that there is something going on, and it's not simply an experimental error.
You need to put back the electrode?
When we first got the excess energy, we weren't sure where that energy was coming from. And so one of the first things that we did was run experiments to determine if there was some degradation in the electrodes or the electrolyte, or if there was a nuclear source. And all of those tests showed that none of those possibilities were likely. There was no other source for this heat other than some unknown process.
Because Thermocore is a contractor for the American military, news of this huge excess power gain caused quite a stir. And a senior scientist at one of the national laboratories promptly went to work on it. He doesn't wish to be identified because of the stigma of cold fusion research.
I have to be careful about the jobs of my colleagues, for instance, and a whole laboratory can suffer from having one individual who's too far out of the mainstream. If work on this at a national laboratory were known, it would lessen the position of that laboratory. It would make it much more difficult to obtain funding or sustain your research activities. It could, in fact, close them down completely.
Ignoring the risk to their reputation, a small team of researchers went to Pennsylvania to investigate Thermocore's claims.
What we saw at Thermocore was so exciting that we decided we had to get into this right away. My colleagues at another national laboratory were successful in obtaining funds. A program was started. We're very encouraged by the early results, and the program is continuing. I think Thermocore is onto something. It's just not clear to what extent it can be scaled up for full commercial use. That's the question that remains to be answered, and that's what Thermocore is wrestling with now.
For the critics, it is the sheer diversity of claims for excess heat in heavy water or light water with nickel or palladium combined with a lack of consistent evidence for either a chemical or a nuclear process, which makes them still deeply skeptical about whether there's a phenomenon there at all.
Earlier in this century, a very distinguished chemist by the name of Irving Langmuir defined pathological science as the science of things that aren't true. And I have labeled my book, Cold Fusion, the scientific fiasco of the century, simply because there's no experimental evidence at this point that any nuclear reaction products have been formed. Therefore, the claim that cold fusion is a nuclear reaction process without a commensurate amount of nuclear reaction products is simply pathological science.
It is, of course, perfectly true that there is pathological science. People do occasionally believe something which is just plainly impossible. And the history of the subject shows it is impossible. However, there are many instances in science where it is not pathological science, but it's pathological criticism, where the evidence, in the end, has been found to be absolutely correct, and the critics were pathological. And that is always forgotten. So the question here, the conundrum we have here, is it pathological science or is it pathological criticism? And I would suggest that it is now time for the critics, those who have done some experiments themselves, to go back and investigate their own data and see whether it would not be more reasonable to say that they had observed the same phenomena as we had observed.
At MIT in Boston, one man has gone back to check the data, and what he found made him so angry he quit his job in protest. Dr. Eugene Malov, former chief science writer for the MIT News Service, believes data was manipulated to debunk cold fusion.
The whole point of science and technology is to seek new things, new anomalies that have to be explained and can be used for the betterment of humanity. Here we had one in cold fusion, and instead of investigating it thoroughly and getting to the bottom of it, what we had were top-level people at MIT disparaging cold fusion, attacking cold fusion, manipulating the press against cold fusion, doing everything possible to show the public and the world that cold fusion was nonsense.
The Plasma Fusion Center at MIT, one of America's leading centers of hot fusion, with a $20 million research grant, was one of the first places to claim there was no evidence for cold fusion. About a year after the experiment was done, Malov saw a graph of the raw data for the first time.
That's what I thought originally. Now,
the spiky line of temperature readings seemed to him to show excess heat above the baseline, but the graph that was actually published shows an average of heat measurements right on the baseline, suggesting no excess heat. When the two graphs were superimposed, it looked to him as if the published data, the curve shown in blue, was lower, showing no excess heat.
When I saw this data, I was outraged. I couldn't believe my eyes. For years, the MIT results showing no excess heat have been held forth to the world as an example of an experiment that didn't get excess heat. This is not true. And the fact that that experiment continues to this day to be used by the Patent Office and many other people as examples of how cold fusion failed in 1989 is a travesty.
What you finally see in journals generally has some processing associated with it. And so, yes, it's correct to say that what appeared in the paper looks different than the raw signal coming out of the detector itself. This is a normal situation, completely normal. But it was our judgment that in processing the data, we didn't change its content. We only made it clearer.
We asked about Malov's suggestion that the data was manipulated to show no excess heat.
It's complete nonsense, utterly ridiculous and without foundation. And any allegations along those lines, I believe, are made by people that don't understand how measurements are made.
At Cornell University Cold Fusion Archive, Dr. Bruce Lewinstein believes this sort of wrangle over experiments is typical of many others in the history of science.
Experiments turn out to not be the clear-cut windows onto nature that they're often presented as. They're subject to a great deal of interpretation. No matter what you do, if you cannot replicate an experiment, the other person can always say, you're doing something wrong. And this will go on forever. That one person says you're doing it wrong, the other person says I've tried it, and they go back and forth. Science is often portrayed as being objective, as being a purely rational and objective inquiry into nature. In fact, sociologists and historians and philosophers of science over the last generation have been showing how much science depends on individual value judgments, on the ways that scientists get their funding or frame their problems, how much of their own concerns enter into their research. And that leads to a science that is not arrived at through this textbook rational approach. Instead, it's a science which is shaped fundamentally by the humans who are doing it.
As if claims of pathological science, fudged data, and the end of quantum mechanics were not enough, tragedy was about to strike a cold fusion lab. It was Christmas at MIT. Fleischmann was invited to lecture, and what he said had a profound effect on one member of the audience.
We learned that Macubre's lab on the West Coast was still doing experiments with bulk palladium samples. Fleischmann admitted that he no longer worked with bulk samples because he viewed them as too dangerous. A cold fusion cell is extremely dangerous. You have a lot of stored hydrogen, a great density of stored hydrogen. If you store a large quantity of hydrogen in a palladium lattice and you drop it or you knock it, it can spontaneously explode. And if that palladium apparatus is inside a containment vessel, it can act like a grenade.
He tried to reach researchers at Macubre's lab to warn them of the dangers of using bulk samples.
From Christmas until New Year's, SRI closes its doors. So I called all that week in the hopes that someone would come in and I could alert them to the danger. They didn't return until the first day after New Year's in 1992, and I called early that morning. I called as late as 11 o'clock Eastern Standard Time. However, that was still just getting to 8 o'clock out at Stanford, and there was no answer. At 11 o'clock, 11:30, I went off to lunch to play in an over 30 basketball game, and that lasted some time. And when we returned, then I tried to make those calls again, and it was already too late.
That morning, there was an explosion at Stanford Research Institute. A young research chemist, Dr. Andrew Riley, was killed.
Obviously, as a consequence of something as traumatic as that, you reevaluate what it is that you're doing and why you're doing it. And each one of us independently examined whether what we were doing was important enough to warrant continuing with the research. And in each case of the people in the research group, we felt that what we were doing was far too important to put aside, despite what was obviously a potential consequence and what obviously had occurred.
It took Macubre a year to rebuild his laboratory. A special regulation was passed in California permitting cold fusion research only behind half-inch thick blast-proof safety barriers. But funds from the American electricity companies are continuing, and they're reporting up to 500% excess heat from some cells. In France, Fleischmann claims even more extraordinary results. He says if they increase the current and let the cells boil, they get dramatic excess heat releases. In some cases, if they let the cell boil dry, or switch it off completely, the cell remains hot for far longer than one would expect. They see the next step as an engineering problem, how to maintain such high heat releases for longer periods of time.
This is the device with which we are aiming to try to maintain boiling conditions for about 3 months at about the 500 watt level. So the bottom section is very much like the systems we have used before and is intended to allow us to drive the whole system to boiling conditions. But when it is boiling, of course, normally we lose all the heavy water, the steam, so the top section returns the steam as heavy water to the bottom section. And we are going to try and achieve boiling conditions for 3 months. Of course, the whole design is a scale-up of about a factor of 3 on what we did last year.
Last December, the Japanese government announced a further $30 million to set up a new hydrogen energy institute dedicated entirely to cold fusion research. Fleischmann was invited out to Japan to advise them on the technology.
Unquestionably, if there is a technology waiting to be realized, it will be realized. And we are very pleased that we are playing a part in that. Will you have that sort of source of energy for a car? Why not? Why not? I don't know, but if you can make it work, if you can get sustained heat release at a reasonable temperature, then the technology is there to exploit that heat.
When we have our new institute,
yes,
the Shinto priest from this shrine comes to
bless.
Bless, yes.
To bless. The new institute will be based here at IMRA. 20 major Japanese corporations are financing the project, including Hitachi, Toshiba, and Mitsubishi. And 100 university-based projects will be started. The aim is to try to confirm the claims and ultimately make a power cell. After a few frantic days of presentations, Fleischmann and his team went out to celebrate the beginning of this new project, which they've nicknamed Icarus.
This is supposed to be a balance of the idea.
So, Icarus 1. And all the other Icaruses to follow.
Yes.
And don't forget, our wings are stuck on the super glue.
And the success of our sponsors.
Yes. Kampai.
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 While the wrangle over the science continues, in America, the venture capitalists can't wait. Fred Yeager, president of a company called Eneco, has flown around the world buying up patents and patent applications just in case cold fusion is real.
Our company has spent in terms of millions, not tens of millions, on this project. You can't afford not to get involved at this from a patent point of view, because even though the technology or the science isn't known, we're to the point where you could replicate and amplify it. If you wait until then to get into the patent field, it's too late. Suddenly, everybody knows the value of this. The only reason we can survive and do what we're doing now is because it is unknown.
If successful, they believe they might become the OPEC of cold fusion.
There's a gentleman from Texas who is involved in other technical fields and took a look at the risk-reward curves on this particular branch of science, and he's been our main investor to this date. We obviously dream from a commercial sense, if this is successful and we are able to get a handle on the science and license this technology to a worldwide audience, the return is billions of dollars in license fees.
In recent months, cold fusion fever seems to have taken off again.
Our intent is to build a boiler.
This is our first attempt at a commercial boiler unit.
We've seen no reason why it can't be made safe.
We had marked success.
And it'll either be for home heating use or for commercial use.
These cells represent the embodiment of the boiler of the future.
It could be worth millions or even billions.
And there's one person who firmly believes he's beaten the rest of the world to it. Behind these garage doors in Ohio lies, allegedly, the world's first water-powered car, the creation of amateur inventor Stanley Meyer.
This dune buggy operates around 65 miles per hour on around 60 miles per gallon of water. It's very efficient as opposed to running on gasoline. One time I was offered well over $1 billion in cold cash to buy out the technology, to suppress it. Of course, my interest is to get it into the economies of the world and do it very quickly. We've developed the technology over the years, and we've legalized the technology, and now what we're trying to do is coordinate with industry to design kits that can be fitted to an existing internal combustion engine, whether it's a gasoline engine or even a diesel engine.
His kit is not unlike a cold fusion cell, but with very high voltages applied. Skeptics believe it's no more than a battery storage device, but a New York millionaire is paying to have it all checked out in a secret lab in Boston. Although the car wasn't running when we came to film, pictures were taken earlier by the local TV station.
The status of cold fusion is rather like a gold rush. The data has been pouring in so rapidly with a variety of different radiations reported and different byproducts, and we're tantalized by this scientifically. It's just a wonderful opportunity to use all your scientific training to try and understand what's going on here, and we think we're making some headway in that area right now. We're very excited. You can hardly wait to get up in the morning to come in and to continue in this line of research. It's extremely exciting, and it's accelerating. It's just a wonderful time to be a scientist.
It's often asked why people, for example the Japanese, should want to put very large amounts of money into a phenomenon like this. And some people would take that to mean that this phenomenon is a real phenomenon. Well, I find that argument spurious too. For example, a multimillionaire who decides to indulge in eccentricities or to sponsor an artist of some sort is never questioned as to why he should wish to spend his money in this way. And if you have plenty of money to slosh around, as the Japanese have, then why not? In this circumstance, you can consider that you have someone like Martin Fleischmann, who is an absolutely brilliant man. Now, in my view, he's obsessed with cold fusion. But who knows what might be creeping around in a corner of his brain? When you have a man like that, you never know what might appear. And it's worth the odd million to indulge his obsessions. You never know what you might get.
I think it's inevitable that if you have a persuasive, articulate, charismatic man who believes that he's made a very important discovery that challenges scientific orthodoxy, it's inevitable that his students, his colleagues, will have to take a view. Are we for him or against him? And in a way, it becomes quite quickly like the founding of a religion. You have a charismatic leader who persuades some people who become his followers that they have seen the true light. And there's a larger element of that, I fear, in what's happened with cold fusion.
Science is science. Science is truth. And without some morals or something to believe in on this planet, be it God or science or whatever you truly believe in, and what do you have? What do you have? What do you have? What reason do you have to survive? What reason do you have to go on? We did nothing wrong. We made no mistakes in our observations. We made no mistakes.
Le tatou fruit, s'il vous plaît. C'est gâteau chocolat.
Gâteau chocolat.
Le deux.
Chocolat praliné.
Oui, Martin was facing a very lovely retirement. He was facing a very lovely wind down of his career, 5 years ago.
Le deux. Je dois payer. Combien?
166 francs, s'il vous plaît.
This looked like a very good point for him. It would be sort of a crowning point in his career. And the reasons why it went bad have nothing to do with the validity of the science. I'm just very disappointed that a man of his stature was treated this way.
The mainstream of scientists will tell you that conclusion has been reached. Cold fusion is dead, always was dead, but there are a number of people who, by almost any description of what a scientist is, are real professional scientists who are continuing to investigate cold fusion. There's an area of research now. It's cold fusion research. It's not a big area, it's not a well-funded area, but it's an area, and it's now part of the entire scientific research picture.
I've always only done the work which I have wanted to do, and I've never cared about my scientific reputation. I've got to my second revolutionary phase, yes. I was always pretty terrible in my youth, but I've got worse.